Hello dear students. Today in this video I am going to start with the chapter number 6, Combustion and Flame. In chapter 4, when we studying the chemical reactions of metals and non-metals with oxygen, we have done an activity that burning of magnesium vapor. So that was a reaction of the magnesium with oxygen present in the atmosphere, and we have got a white flame in that activity. So we can start from that. So that is a chemical reaction of metal with oxygen. So here we are going to generalize that chemical reaction of any substance with oxygen. It can be metal, non-metal, any kind of material, no matter. That chemical reaction or a chemical process in which a substance reacts with the oxygen to give off heat is called combustion. We already observed that when during the burning of magnesium, it produces heat as well as light also, but not necessarily always light. So burning or combustion can be called in both names. And what are combustible substances? All the substances which catch fire or burn in air are called combustible substances. That means there are some substances which can be burned, they are called combustible, or which cannot be called, they are non-combustible substances. Let's take table 6.1 given in your textbook. Here there are some materials given. We need to classify whether they are combustible or non-combustible based on that property. So wood, you already know that wood is highly combustible because it can be burned easily. And pepper is also combustible because we will burn pepper. What can we say about the combustibility of iron nails? Even if you are going to heat this iron nail, as the temperature rises, its color will change like red, orange, white, etc. Like that it will change. But it never burns. Clear? At normal conditions. So it is non-combustible. Regarding kerosene oil, we already discussed that is a constituent obtained from the petroleum. It is one of the best fossil fuels, so it can be easily burned. That means it is combustible. Stone piece. Just if you are going to try to burn stone piece, as we give more heat to that stone, the temperature of the stone will increase, but it is not going to burn. That means it never reacts with oxygen as in the way combustion takes place. So it is a non-combustible substance. What about straw? Straw will easily burn because just a flame of burning matchstick is enough to burn straw. Charcoal is also combustible, but it will take little time to burn. But still it is combustible. Matchstick is highly combustible because just rubbing matchstick with the surface of the matchbox, that friction is enough to burn matchstick. So it is also highly combustible. What about glass? Glass is at normal condition, it is non-combustible. Clear? So this is all about, we need to understand what is combustion and what are combustible substances. Now let's discuss what are the conditions required for taking place the process of combustion. The substance which we are trying to burn should be combustible. That is a necessary condition because if the substance is not combustible, then the combustion process will not take place. So first condition is that the substance should be combustible. Then what can you think about the second condition? Even the substance is combustible. For example, I will tell you, suppose we take a pepper and kept it undisturbed. Anything will happen? Nothing will happen and this pepper will not burn. So to burn this pepper, what need at least? At least you need to bring a burning matchstick or lighted matchstick near to the pepper, and just for showing 1 or 2 seconds, the pepper will catch the fire. Which means the burning matchstick provides some heat to this pepper, and when pepper attains some heat, it starts to burn. Similarly, even to burn LPG in the household stove, we need to lighten that one by using a lighter. A small spark is required to burn LPG. That means some amount of heat energy is required to burn a particular kind of substance, which means the substance should attain a minimum temperature in which it catch fire. That temperature is called ignition temperature. So the second condition, we can say that the temperature of the substance should reach to its ignition temperature, where it is the lowest temperature at which a substance catch fire. So it should attain its ignition temperature. That is the second condition. And even if these two conditions are satisfied, let's think about one another activity 6.2, which is given in your textbook. Let's perform that activity to get the clear idea about the third condition, which is required for taking place of combustion smoothly. For that, I am going to discuss activity 6.2. First, you are taking in this way. That is, burning candle and a glass chimney is mounted where this burning candle is placed. Also, one more thing we have to remember, we have to keep two small pieces of wooden strip such that the glass chimney should be kept on these strips, so that there will be a gap between this chimney and cardboard. And also you can observe that the candle is burning freely without any disturbance. Now let's take the second possibility here. Here what we have done a small change, that we remove this wooden strip or anything which we kept for keeping the gap between chimney and cardboard, that is removed, so that this glass chimney is directly mounted on the cardboard. Now you can see that this flame is flickering off and produces smoke. And third possibility, that I'm going to cover this glass chimney with another cardboard. At that time you can observe that the flame is completely goes off. So what is the information we will get from these three figures? Let's analyze it one by one. In first case we can conclude that here the candle burn freely when air can enter chimney from below, because there is a gap between chimney and this cardboard. So the air can easily enter through the bottom part. Okay, because of that, candle burn freely without any problem. Now in the second case, it is not completely goes off, but it is flicker and produce smoke. The reason is that air do not enter from below, bottom part or below. The flame flickers and produce smoke, because air can enter through the top part, but that is not sufficient for the combustion. Because of that, it produces smoke and it is flicker the flame. That means seems like partially it is taking the combustion process. And in the third case, see, there is no air because bottom part is also closed and top also closed. That means the flames goes off because the air is not available, because it is completely closed. So we can say that the third condition which is required for the combustion process, that is air. Why it is air? Because in the definition of combustion we said that it is a chemical process in which a substance reacts with oxygen. We know that oxygen is present in the air. Because of that, this condition is required. That is, a supply of surplus or sufficient oxygen or air is required to take place the combustion. So these are the three conditions which are required for taking place combustion. Clear? It's very, very important. Okay. Now let's discuss conditions of this combustion one by one in detail. Okay. First one is the substance should be combustible. That is, we already discussed what are the types of combustible and non-combustible substance. So that's no need to discuss again. Now we are going to discuss ignition temperature. We can discuss ignition temperature of a substance in detail. So here I'm going to discuss like some question and answers. What are the possible situations around us? And we will take the situation and we'll try to find out the answer, so that we'll get a clear idea about the term ignition temperature. So first I'm starting with how does a matchstick burn? In case of matchstick, we know that we are not need to provide a flame. When a matchstick is struck against a rubbing surface, that means striking against a rubbing surface, due to the friction, you can touch the surface of matchbox that is somewhat rough, it's not smooth. So there will be some significant amount of friction and a chemical reaction will take place. enough heat produced to ignite the matchstick. Due to the friction, there will be some chemical reaction. With that chemical reaction, some amount of, because during the friction, there will be some heat will be generated. With that heat, some chemical reaction will take place. As a result, some enough amount of heat will be released. That heat will be sufficient to ignite a matchstick, because we know that friction produces heat. For understanding that, just take a scale or pen and just rub it against this table or any rough surface, and after rubbing to 5 or 10 times, just to keep that scale or pen on your body, you can feel hotness or you can feel a warm, because due to the rubbing there was a friction, and as a result of friction there will be some heat produced. So the same way here also. And as we know that a combustible substance attains its ignition temperature, it catches fire. So once the matchstick attains its ignition temperature due to this friction, as a friction, first it was there is a friction, as a friction there will be some chemical reaction. Due to the chemical reaction, some heat will be produced. That heat is sufficient to attain the ignition temperature of matchstick. When it attains its ignition temperature, it catches fire. This is the way how a matchstick burns. I will give you a link for the video that explain how a matchstick burn in detail with animation. So I will give that link in the notes. Okay, so you can watch that one, so you will get a clear idea about the burning matchstick. And in your textbook also, it is given in the detail. Just read that portion. What are the chemicals used in those? I'm not going to discuss. I'm just discussing in brief. Now, second question with we have: does a pepper burn when a burning matchstick is brought near it? That is the second question. So first we burn a matchstick, and with that burning matchstick, is it sufficient to burn a pepper? Yes or no? Yes. Because usually if you want to burn a pepper, what we'll do? We'll light a matchstick and we'll bring near to the pepper, it will catch the fire. Clear? So the answer is yes, because the heat produced by burning matchstick is enough to ignite the piece of a pepper. That means the ignition temperature of pepper is not much high, it is little low. The next question with is that, can you burn a piece of wood by bringing a lighted matchstick near it? As the way we burn a pepper. Is it possible? Not at all possible. So to burn some firewoods, what will you do? We'll keep the firewoods together and we'll use some kerosene or petrol or pepper or something. What will be the reason? Let's discuss. Here, no. Because the heat produced by burning matchstick is not enough to ignite a piece of wood, because the ignition temperature of wood is high. That much heat will not be generated in the burning of matchstick. So this is because wood has high ignition temperature, and which means it needs more heat to ignite or catch fire. So to ignite or catch fire, what will you do? We need to burn some substance as an initial agent. That question is here. Why do we have to use a pepper or kerosene oil to start fire in wood or coal? Reason is that because the heat produced by burning matchstick is not sufficient to ignite a piece of pepper. So we need to make the wood to reach its ignition temperature. For that, something should burn initially. So the substance we are using it as kerosene oil or pepper, anything. Okay, so let's discuss the answer in detail. As pepper or kerosene oil have low ignition temperature. We already know that pepper and kerosene oil can be burned with matchstick because it has low temperature, so it is easy to burn it with a burning matchstick. Once this started burning, it produces enough heat to ignite coal or wood. So first we will burn pepper or kerosene oil with a burning matchstick because their ignition temperature is low. Once this pepper or kerosene oil burns, it produces large amount of heat. That heat is sufficient to make the wood or coal to reach its ignition temperature. When this wood or coal reaches its ignition temperature, then it starts burning. So from all this discussion, we can conclude that all the combustible substances do not have same ignition temperature. Different combustible substances have different ignition temperature according to the chemical and physical properties of that. So this is all about we need to understand what is ignition temperature and what is the range of the ignition temperature. So we can arrange the substances in the increasing order of their ignition temperature. If we are going to list some substances, we can say that LPG. LPG has lowest ignition temperature around us, the substance which we see around us. Because we know that to burn LPG in the stove, what will you do? We just light this lightener. A small spark is produced in the lightener for a fraction of a second. That spark is enough to burn or to ignite LPG. That means the ignition temperature of LPG is very much low. The next we can take petrol. Petrol is also one of the substances which has low ignition temperature, but compared to LPG, its ignition temperature is little high. After petrol, we can say kerosene oil. This is also, you may be observed that while you're bringing a burning matchstick near to petrol and kerosene oil, you can say that, you can observe that petrol will catch the fire suddenly, while kerosene oil burns slowly. That means the ignition temperature of petrol is lower than the ignition temperature of the kerosene oil. And the next pepper. Pepper and kerosene oil is almost have same ignition temperature. Depend on the pepper. Okay, if you are taking a fine pepper, it will have a low ignition temperature. It should be dry. And in case of thick pepper or cardboard like that, then it will not be having low ignition temperature as in the case of kerosene oil. Then will come wood or coal. I think coal has highest ignition temperature because to burn coal, I think we need to burn either kerosene oil or wood. Pepper will not. Pepper is also not sufficient to burn some pieces of coal. Coal has highest ignition temperature. So this is the way we can classify the substances according to their ignition temperature. And also this ignition temperature depends on the dryness of the substance, whether the substance is wet or dry. When we try to burn dry leaves of plants, it catches fire easily. It is because there is no moisture content in the leaf. While if you try to burn green leaves, it's not possible because there is a presence of moisture. So due to if the moisture is present in a combustible substance, it does not allow to reach the substance its ignition temperature easily, because the heat supplied to that substance will be absorbed by the water or moisture present in that combustible substance. So the dryness of the substance is also a factor that determines its ignition temperature. So if the substance is wet or if it has some moisture, it makes its ignition temperature higher than the usual ignition temperature. So that is also a factor you need to remember regarding ignition temperature. I also said that there are some substances which have a low ignition temperature. Such substances are called inflammable substances. The substances which have low ignition temperature and can easily catch fire are called inflammable substances. Like LPG. LPG is an inflammable substance. Petrol. These all are inflammable. Those substances have low ignition temperature. If they have low ignition temperature, then they can catch fire easily, even by a spark or burning matchstick. That's enough. Clear? So this is all about you need to understand regarding ignition temperature. Okay, now let's move to the next condition we have discussed, the presence of air, that means supply of oxygen. So what will happen if the supply of oxygen will not be there? So presence of air or supply of sufficient amount of oxygen is necessary for taking place combustion. So if there is some lack of supply of oxygen, then the combustion will not take place completely. It will take in the partial manner. That is called partial combustion or incomplete combustion. A combustion which entails only a partial burning of a fuel or combustible substance. This is maybe due to the lack of oxygen or low temperature. That is the second condition. Low temperature is also a reason for the incomplete combustion. But most probably this will be the reason why that lack of oxygen. So the substance will not burn completely, instead of it will burn in the partial manner. That means it leads to incomplete combustion. I already discussed in the chapter 5 regarding the saving tips of the petrol and diesel while we are driving, that if the from the exhaust of the vehicles, if the color smoke comes, it indicates that incomplete combustion. That means lack of oxygen and low temperature, both are the reasons, but this is the main reason it may happen for this incomplete combustion. You can see this is representing complete combustion. This is representing complete combustion without any smoke. But this is the second figure, down figure, is representing incomplete combustion of the same wood. Here smoke is produced, which indicates incomplete. Here there is no smoke, burning smoothly. That is complete. In case of gases also we can say the blue flame. Here in the first figure it is representing complete combustion because its color of flame is blue, while in the second case that is incomplete combustion of the same substance. Okay, because color of candle flame is yellow and color of LPG flame is blue. One is incomplete, one is complete. We cannot say that. When we have to take same substance, in case of LPG or in some gases, we already know that while it burns, it produces blue flame. I think you already noticed that. So, but if it is produced sometimes yellow or orange or the flame other than blue, then it indicates that incomplete combustion. You can observe this in your home itself. If the lack of air is present in the kitchen areas, then you can observe the color of the flame will be changed to red from blue. It indicates that incomplete combustion. From the color of flame also we can identify whether it takes place incomplete or complete combustion. And one more thing we need to remember regarding incomplete and complete combustion, that is carbon monoxide is produced. Carbon and mono means one, carbon and one oxygen. So that is produced as a byproduct from the incomplete combustion of carbon, because this is the product we get after the reaction of carbon with oxygen. So this is in case of incomplete combustion, and carbon monoxide is the one of the most poisonous gas. And carbon dioxide will be CO2. Two oxygen will be the one. Carbon will be combined with the two oxygen. Carbon dioxide is produced as a byproduct from the complete combustion of carbon. So this is the major differences between the complete combustion and incomplete combustion. This is the reason why it is advised that we are not supposed to close the rooms, especially during the winter time, by burning charcoal inside the room. Because burning of charcoal in a closed room leads to incomplete combustion, because once the amount of oxygen used by this carbon or charcoal, then it leads to incomplete combustion due to the lack of oxygen. While during the incomplete combustion, carbon monoxide is produced, and this produced carbon monoxide, if it is intake into the body of humans or any organism, it will lead to the death. Clear? So that is very important. So it is advised that we are not supposed to close or shut out the doors while we burning charcoals in our home or rooms. So this is all about the third condition. So we have discussed all the parameters regarding the combustion. Now we know that combustion is a very important phenomena in our daily life, because to cook, to get heat, especially during winter, for many purposes we are depending upon combustion to get heat. This all combustion take place in controllable manner for our useful purpose. Suppose if this combustion take place in uncontrolled manner, it leads to a huge disaster. So it's very important to know how to control the fire if it happens. So now we are going to discuss how to control the fire. Here, this section also I am going to discuss some questions and answers. How to control fire? We know that three conditions required for taking place combustion. So only the possibility is that these three conditions should be eliminated. Then only we can stop the fire or control the fire. But removing fuel or the burning substance is not applicable in most of the cases. For example, one building is burning. It's not easy to because the all the substances, all the combustible substances inside that building becomes fuel. It can be table, chair, bench, everything. So it is not easy to remove or eliminate those ones. So we need to eliminate other two conditions. First one is to reduce the temperature. That means we need to bring the substance below its ignition temperature, and the second condition we can do, that one is blocking the supply of oxygen. So this is the way we can control the fire. Clear? So fire can be controlled by removing one or more conditions under which combustion take place. What are the conditions we can remove? Supply of oxygen and bringing the temperature of substance below to its ignition temperature. Now, how fire extinguisher works? Fire extinguisher is a device or instrument which is used to stop the fire. Fire extinguisher cut off the supply of air or to bring down the temperature of fuel below its ignition temperature. These all things I already discussed. Temperature or both. Either one or both can be. Notice that fuel in most cases cannot be eliminated. So this is the way how a fire extinguisher works. Now let's discuss the next question. Water is the most common fire extinguisher. We already know that because water can bring the temperature of substance to below to its ignition temperature. In normal case we are using. But it is not suitable for fire involving electricity, petrol, oil, etc. For common purpose, like for example in our near to our house, suppose a small portion of a forest or some trees are burning, we can bring some buckets of water and pour it. It will be put off the fire. But the fire involving electricity, oil, like that substances, is not suitable to use water as fire extinguisher. Why? Let's discuss the answer. First one, in case of electricity. In case of electricity, the reason is that water may conduct electricity and harm those trying to douse the fire or stop the fire. That is the first reason. And in case of petrol and oil, I already discussed in chapter 5 that water is denser than oil or oil is lighter than water. So water is heavier than oil, so it sinks below the oil and oil keeps burning on the top. So once pouring water will go down, sink into below the oil, and oil will come up and it's burned freely. So because of these reasons, the wire involving oil, petrol like that substance, or electricity, water is not used as a fire extinguisher. Then what can be used? Then what will be the best fire extinguisher which can be used as an ideal fire extinguisher in all the cases? So the question in front of us, that is, which is the best fire extinguisher suitable for fire involving electrical equipment and other inflammable substances? The answer is the carbon dioxide. Carbon dioxide is the best fire extinguisher which can be used in all the cases. Why or how it works? That is the next question. CO2 being heavier than oxygen. That is the reason. CO2 is heavier gas than oxygen. So if it is heavier, what will happen? It covers fire like a blanket, because it will go below the oxygen and it will cover the fire as a blanket. Since the contact between the fuel and oxygen is cut off, once the carbon dioxide is go below the oxygen and cover the fire as a blanket, carbon dioxide will be in the middle of oxygen and the fuel. So the contact between the fuel and oxygen is cut off. Then the fire is controlled. That is the one way. In addition to that, sometimes CO2 is stored at high pressure as liquid in a cylinder. I already told you, like in case of LPG, liquefied petroleum gas is stored as liquid by applying high pressure in cylinder. So similarly, carbon dioxide is also sometimes stored as liquid in the cylinder. Sometimes powdered agents also will be used. Okay, different type of fire extinguisher are nowadays available. So I'm taking one example only, that So in that case, when it is released from the cylinder, the CO2 expand enormously. That means CO2 is stored as a liquid under high pressure. When it is released from the cylinder, it expand enormously and convert into the gaseous state. During the expansion of carbon dioxide from liquid to gas, it absorbs heat from the surroundings. That means its volume increase and is cooled down and bring in the temperature of the fuel. It absorbs the heat from the surroundings means it absorbs the heat from the fuel and it bring down the temperature of the fuel. So that is also enables to control the fire, because when the temperature of the fuel becomes below its ignition temperature, that is also become an agent to control the fire. So this is the way how carbon dioxide is controlling fire, and it is one of the best fire extinguisher. Nowadays, different type of fire extinguisher which produces carbon dioxide are available. Like you already have seen that this is the fire extinguisher which produces carbon dioxide. Sometimes it is directly stored as a gas. Sometimes it will be stored as in this form of some chemicals. When it releases, it produces carbon dioxide. In that way, in different ways it is stored. The chemicals powders which are used for getting carbon dioxide are sodium bicarbonate, or we can write the chemical formula like N, so NaHCO3, sodium bicarbonate or potassium bicarbonate. Potassium bicarbonate, KHCO3. So here sodium bicarbonate is this is so what are the materials present here? Sodium is the hydrogen, is the carbon, oxygen. These three are non-metals, while sodium is a metal. Similarly, potassium, its symbol is K, so it is a metal, and hydrogen, carbon, oxygen, these are non-metals. So this is all about you have to remember how to control the fire. So moreover, you need to remember the fire force number. In case of any emergency, we need to call fire force, because sometimes it cannot be controlled by us. In that case, we should not try to put off the fire by ourselves. Instead of that, we need to seek the help of fire force appointed by the government. Clear? So that is also we need to remember regarding controlling of the fire. Now we are going to discuss the last topic of this video, types of the combustion. There are three types of combustion. One is rapid combustion, spontaneous combustion, and explosion. So let's discuss one by one. First one is rapid combustion. Rapid combustion is the combustion that takes place rapidly and produce heat and light is called rapid combustion. For example, burning of LPG. When you bring a burning matchstick or lighter, sparking lighter to near to the LPG, obviously it catches fire rapidly and produce heat and light. So in that case, that is a rapid combustion, the combustion which takes place in rapid manner. That's all. Like LPG, petrol, these all substances will undergo the rapid combustion. Next one is that spontaneous combustion. Spontaneous combustion means from the word itself we will get the idea. It takes place spontaneously without any apparent cause. The type of combustion in which a material suddenly bursts into flames without application of any apparent cause is called spontaneous combustion. If you just keep that substance in the atmosphere, or if it is exposed to oxygen without any flame, without any spark, it bursts or it burns itself. Such types of combustions are called spontaneous combustion. For example, phosphorus burn in air at room temperature. Phosphorus is one of the highly inflammable substance, because without any spark and flame, it can be burned at room temperature. You can see in this video that sulfur is burning. Clear? So without any applying any flame or spark, it is burning spontaneously. So this is all about spontaneous combustion. And the last one is the third type of combustion is explosion. That is a reaction that takes place with the evolution of heat, light, and sound All in a sudden, when something would ignite, and a large amount of gas formed in this reaction is liberated. Such a reaction is called explosion. That means a large amount of fuel burning in a fraction of a second. That means combustion of large amount take place in a small time period. That is leads to the formation of light, heat, and also sound. So that is called explosion. Clear? In case of crackers, bomb, these all are explosion. This is also a combustion. Clear? So this is all about the types of combustion. Now some more topics are left in this chapter that I will discuss in the next video. So for today, I'm going to wind up this video now. So that's all for today. Thanks for watching.